Hey guys, welcome back to my channel. So today we're going to solve this problem called climbing stairs, and I'm going to show you four approaches to solve it. First will be the brute force recursive approach, second will be top-down DP, third will be bottom-up DP, and fourth will be space optimized dynamic programming. Okay, so let's first understand the problem. Climbing stairs. In this problem we are given a number n, and the question is asking us to determine the number of ways that we can climb the stairs to the top. What are the number of ways and how do we generate the number of ways? See, at every step we have two choices. Either we can climb one more step or we can climb two more steps. So if n is equals to 3, I hope you can see this. If n is equals to 3, then we can climb one stair, then one, then again one, or we can climb one stair and then climb two stairs at a time, then climb, or we can start with two steps and then go one step and then reach the third step. um, so what we're trying to do is we have to return the number of distinct ways we can climb, total number of distinct ways that we can climb the to the top of the stairs, to the nth stair. Okay, so let's recognize this problem. This problem requires us to generalize this solution for any value of n. So let's see, when n is 1, there is only one way to climb the stair. If n is 2, there are two ways. If n is 3, then there are three ways. As you can see, we can take 1 step, or we can take 1 and 2 and then 2 and 1. So again, for 3, uh, for n equal to 3, there are three ways. For n equal to 4, when n is equal to 4, there are five ways. How? Let's see. So first we can again go one step at a time, or we can go one step, then two step, then two step again, or we can go two step, one step, and then two step, or we can go one step, then one step, then two steps. This is 4, right? Yeah, this is 4. This comes to 4. And oh, sorry, I made a mistake here. It should be 2 comma 2. And here also it should be 1 comma 2 comma 1. Right. So this is just 4 ways. The fifth way would be two steps, then one step, then one step. All right. So we have seen that there are 5 distinct ways uh, to reach the fourth step. Okay. So when n is equals to 4, there are 5 ways. Are you noticing a pattern here? The answer to the nth value would be the sum of the previous two values, n minus 1 and n minus 2. See, when n is equals to 4, the answer is equals to uh, answer of n minus 1 plus answer of n minus 2. When n is when n is 2, the number of ways is 2. When n is 3, the number of ways is again 3. So at n minus 1, we will have 3, and at n minus 2, we will have 2. And similarly, if we go on for 5 steps, there will be 8 ways. I can again show you all the permutation combinations, but my answer will be correct. So what are we essentially doing? We are essentially getting a Fibonacci series where the current element is the sum of the previous two elements. Okay. So how can we solve this? Let's think of a recursive approach first. In a recursive approach, we know that the answer is equal to the last value and second last value, sorry, last value plus second last value. So if we code this up, let's say n is greater than equal to 1 always. So we can say if n is equals to 1, there's only one way we can climb the stairs. If n, otherwise we can say that there are n minus 1 plus n minus 2 ways of climbing the stair. Sorry, we will call the function recursively and say that whatever this function call returns will be the sum of these values will be the answer to the current n. Okay, and we should add a less than here, because when we subtract 2 from n, it might go lower than 1. So we should add this one here, this less than equal to, and let's check if this works. Okay, this works fine. But if you see, n can be less than or equal to 45, which means at every call we will, and this two function calls mean that at every function call you will have two subsequent function calls to climbing stairs, which means if n is equals to 45, then we might have 2 to the power 45 function calls, which is a lot, and it won't pass the test cases and the time limit also. We'll get time limit exceeded if we do this. All right, how can we make this better? Let's store the results. Let's store the results in a map of int, let's call it dp, and we'll store the previous results. Why do we want to store the previous results? See, when n is equals to 3, we already know through recursion that what is the value at n equal to 2 and what is the value at n equal to 1. So if we have these two values recorded, then we can answer n equal to 3. So we'll use the map with that purpose, for that purpose. We'll check here if dp dot find, if dp map has already seen this value before. If we have already an answer to this, then we can just return it. Return dp at n, and we also have to assign it. dp at n would have an answer equal to this value. All right, will this work? Let's check. Yes, this works, and it will also submit, but let's not go there right now. Let's go to the, so this is the top-down approach. Why it is called the top-down approach? Because we are taking the problem from the top, from the big problem, and dividing it into sub problems. So we begin with the whole problem at first, and then we keep dividing and until the recursion tree reaches the leaf nodes and gets the answer, and then reverts back to the top, and then returns the answer to the first function call. That is why it is called a top-down approach, because the structure is like that. In bottom-up DP, we start from the sub-problems and then reach the answer to uh, the main problem. Okay, so this is top-down. So let's just comment it out and code our bottom-up approach. And how do we do that? let's say int climb stairs int n. All right, first we copy the base case, then initialize the values that are in dp array, and then convert the recursion to iterative approach. Okay, so let's begin. For the first step, let's say if n is less than or equal to 1, we will straight away return 1. Okay, initialize the values that are in dp array. Okay, how do we do that? Let's say we already know the answer to dp at 1, it will be 1, and dp at 2 will have an answer of 2. Convert the recursion to iterative approach. How do we do that? So we know that dp at n, we have written that dp at n will be equals to climbing stairs n minus 1 and climbing stairs n minus 2. Can we also say that dp at n is equals to dp at n minus 1 plus dp at n minus 2? Yes, we can. So, and let's just start the loop from the third value and go on till n, iterate I, and just copy this here. So we have to decide the range of the values that the dp at n can have, the n can have, and this n we will change to I. And then just return dp at n. Let's check if this works. Let's check if it submits. Yes, it submits. All right, so we have already seen 3 approaches. Now for the fourth approach, what we need is an observation. What is the observation? The observation is that we only need the last 2 elements. So why are we using a whole map and increasing our space complexity to O of n? So we can totally eliminate the map and instead just use 2 variables, int a and b, and let's say a is equals to 1 initially and b is equals to 2, and for the answer we can have an answer variable which is initially let's say it is not assigned any value initially. Okay, we start at 3 and let answer be equals to 2. All right, and we start at 3 and we say that answer will be equals to a plus b, last 2 values, and a new a will be equal to b and a new b would be equal to the current answer, and what we return in the end would be answer. Let's check if this works. Yes, it works. So what we're doing here, let me just explain it again. What we're doing here is that we are assigning suppose we have 1, 2 and 3, and at the n equal to 4, we will have the answer 5. So if we are at 5, we know that we need the sum of 3 and 2. But since we have already assigned answer equal to 2 plus 3, the 2, the A needs to move on to 3 and the B needs to move on to 5 for the next iteration. And let's just submit this and check. So finally, we have completed all four solutions for this problem. The first problem had a time complexity of 2 to the power n. The top-down approach had a time complexity of O of n because of memoization. And the third approach, the bottom-up approach, had a time complexity of O of n again, and a space complexity of O of n. Both the top-down and bottom-up approach had the time complexity and space complexity of O of n. And for the last solution, the space complexity is O of 1 because we are not using any extra space, and time complexity is again O of n. Thank you.